Okay, so what you're looking at here is something that was invented by our team leader a number of years ago, and this is a simulated version of that. And the device is called the ether-spheric modulator, which basically contains 10 light sources that are controlled by their independent bit streams that are being produced by electron tunneling quantum noise sources. And so very often what we see when a large group of people or even a small group of people come together and meditate around it is that these colors go into coherence. And because this is a simulated version, we added a couple of extra things to it. For one, on the right you can see the color change, the frequency at which colors change, which happen when the bit stream hits a certain z-score threshold of a mean shift in bits. So for example, producing more ones than zeros or more zeros than ones, either one of those. And comparing to how much you'd expect the color shift to happen by chance. So when we see that blue squiggly line jump above that green line, that indicates that we're in a state of coherence. Another way to look for coherence is not just the frequency at which the colors change, but the actual unification of the colors. So if, for example, you see these all appearing blue, then you would get a spike in the lower graph where you see color coherence, which shows odds against chance of that particular color frame. And these basically change every a little more than every minute, but they take about 10 seconds to fade from one set of colors to another when it hits a threshold that activates a change. And to give you a sense of the language oracle aspect of this, we included words that are being selected by the bit stream that are changing every second, as well as the time down to the microsecond, and what we call the time dilation factor at the end, which indicates the whether that particular sample of bits had more zeros than ones or more ones than zeros. And so the higher number you get there at the end, that's another way of looking for coherence. That number can be up to 8 because for the word part, we're sampling just the last 2 bits it took. This is taking around 1,000 bytes per second, so it's moving pretty fast. So now we're going to look at the hypercube, which is something that we hope to be building soon. It's the same idea as S.C.R.E.A.M, but with the lights arranged in a different set of patterns, such that you get a hypercube shape. And the same ideas apply about color coherence, which you can see on the bottom. When this all turns purple, for example, or mostly purple, you'll see a big spike at the bottom. Purple, green, blue, any color that's unified. When it's looking more like popcorn, random colors everywhere, that'll be lower on the chart. And yet again, you have color change that's triggered by a mean bit stream threshold, or in other words, a 1 minute running average of the mean value of the bits. And in addition to that, for this shape, you can also see some rotations happening, and those occur when it reaches a threshold as well. And so we have another graph showing how often the rotation's happening compared to what you'd expect by chance. And we see this as kind of a metaphor for the structural complexity of human consciousness. So this is something that has actually been featured by our team leader at several events, including World's Fair Nano and Maker Faire in the San Francisco Bay Area. And basically, this is a pyramid with the 3 levels, and as you can see, you can click and drag it around to kind of get different views. These are all 3D shapes. And this is a simulated version of it, but with the lights on it, which, we hope to be upgrading our real-life pyramid to look more like this and behave more like this. And the same principles apply. You get color changes and color coherence as indicated by the top and bottom graph. This one does not rotate on its own when it reaches different coherence thresholds, so that center graph does not really apply to this. And one other thing of note is this pyramid was selected by Intel as one of the top 24 invention ideas in the country to appear on America's Greatest Makers, which unfortunately was canceled after Trump got elected. And last but not least, here you're looking at the sphere. Now, this is, again, something that we're hoping to build. And the way I kind of envision it is it could be something similar to the Waterford crystal ball in New York City on Times Square, the one that's used for the ball drop every year. And they've actually recently upgraded that to keep up with the times on the LED lighting capability. And so this could be used, for example, in party settings where you have a countdown to a specific event and a lot of people are focusing on that one moment in time. And we would be able to look for interesting correlations in the colors specifically around that time and compare that to when the ball is just sitting there doing its thing. Yet again, you have the color change thresholds being recorded and the color coherence on the bottom chart, and this one doesn't auto-rotate either. And I think that's all I wanted to say about the sphere.
So here is the XYO coin app and a typical setup for a data miner. And again, this system is live and active. You can go to Halo AI, check out our gear page, and there's a link where you can download our coin app. And
HaloAI.me.
yes,
Right? Just to
HaloAI.me. And here is a map of if we were driving, it would be driving along with us and collecting data as it moves. And you can see right here the data is in the form of coins. As you travel, you collect these coins that are exchangeable for cryptocurrency, Ethereum. And I currently have 11,000 coins, which you can also here go in and exchange them for Ethereum. There are various, here's a DNA test kit, Amazon Echo, various devices here. So an AirPod is 352,000 coins if you want to do that. Total, I currently have about 1.8 million coins. It's several $100s. And I've received that just from driving around the Bay Area, collecting data over the last year as part of this experiment. So I am an XYO millionaire based on this. And this is what gave us originally the idea was to utilize AI to make a better version of this combined with rideshare. That was kind of where our mind was in the development process when the outbreak happened, and then with some retooling and rethinking it, I figured out that it was probably a really good contact tracing, and when you combine that with AI, what we have is a total digital vaccine solution. And again, this isn't in any way meant to replace like the pharmaceutical vaccines, but rather as a tool that would actually aid in the vaccine disbursement, keeping track of the effectiveness of the vaccines and how they actually roll out within the community. So the basic tools for miner is going to be an app. This is on a pad, but it could also work on a phone. A Raspberry Pi with the Bridge software. And then here we have BLE Sentinels. And BLE is Bluetooth low emitting energy. And then right here, we also have the NFC card version of the same thing. So you could have, and what this is a basically records every Bluetooth signal it encounters, and it has about a 100-foot line of sight range. So it records them, and then if by chance, let's say you're walking down the street, somebody else walking down the street has one of these, and they link, they actually exchange information. And how these are key with social distancing is that they're battery operated, and when they exchange signals, the strength of the signal is determined by how far apart they are. So in our algorithm, and when we define the value of a node, an exchange, depending on this the perspectives, if these are two strangers walking down the street, and according to the system, they should be social distancing, coming close to each other, let's say within a few feet, that's going to give a much lower score than, let's say, 10 or more feet apart. And that will, if people know that, that will incentivize them to stay at least 6 feet apart, because they know the potential. If somebody else is carrying this, they're actually going to get paid more to cross the street, or to move out into the middle of the curb, or off the curb, just to get that 6 feet plus in between people that you should. And that is one of the key elements of our social distancing strategy. And then when you get back to your home base and it comes in contact with the bridge then takes it, uploads it to the XYO network, and there it can be used forever as point of origin data. And so these are the basic concepts, and how this could actually be used for contact tracing is if you have multiple versions, you can actually register them. So here under referral reward, you see that I have 3 people, just part of our group, who have downloaded our link and that are using it, hooked up to my account. So here, these are all of the Sentinels that I have out. So one account and 7, how many? 3, 6, 7 devices that are actually out floating around, hooked up into my account. And so you can imagine, in a testing center, let's say a municipality adapted this, and people who got uh, vaccinated and tested on a regular basis, instead of just getting a piece of paper, they get one of these cards that every time their diagnosis changes or is updated, it automatically gets updated on the card. And a municipality could have tens of thousands of these floating around as nodes. And what's really interesting, I think, about this is you could have complete coverage of a community with only about 20%. If you only had about 20% of the community active using this, then you would have a pretty wide coverage. That's just sort of an educated guess on my part. Okay, and so how this worked with the model, Dr. Caputi here will add a little bit more to that.
So the model here that we're going to develop, you're going to see a number of costs that are basically our own. And we basically ran the model that was, or a version of what was in the sandbox on Halo. And the costs were come up with basically through Leo's experience geomining these coins and the effects they've had, as well as prior experience coming up with some ballpark estimates of what the non-pharmaceutical intervention costs would be for each item under this blockchain solution that we're going to propose.
So this is how the system is set up now to your everyday geominer. And what we're going to do is watch a brief video from the XYO Foundation explaining what the network looks like and the concept of geomining and point of origin blockchain technology. And then after this video, we'll get into and show you how our technological innovations sort of turbocharge this setup into a manner that collects 10 times, at least 10 times more data just as fast.
Cryptocurrency smart contracts automatically execute contractual obligations, cutting out the middleman. These smart contracts have one downside. There's no single authoritative and decentralized way to execute a contract based on locational data. For example, there is no way to create a smart contract that allows for payment on delivery for e-commerce orders. The XYO network is meant to solve this problem. It's an ecosystem of devices which communicate with one another to create an unalterable history of interactions and locations stored on a blockchain. A user can independently verify that an item tracked using the XYO network was in a defined place at a specific point in time. Since XYO network devices talk to each other, every user augments the other. A delivery driver can help find your lost bike, or your parked car can help confirm your neighbor's package arrival. Users are rewarded with XYO tokens whenever data they provide is used to help another user track or locate an item. Thanks to a unique proof of origin algorithm, the provided data is always valid and up to date. The XYO network, bringing the blockchain to the real world.
And our innovation is this. This is a Raspberry Pi running the XYO bridge network. You can see I'm the bridge owner. This is hooked up into a 7-inch screen, commercially available screen, touch screen. And here you can see that I've got it set up, Halo. This is Halo set up as an archivist. And so what we've done is we've put this into a mobilized version by adding our own battery pack to it. And what we've done is added an Ubertooth one. This retails for a little over $100. And with this antenna hooked up to either here or any stationary location or a car. This is actually built for a car, where we have this hooked up to an antenna on the roof of the external car, capturing not only Bluetooth, such as this, but all other signals, such as Wi-Fi, and I think everything except commercial radio. So Wi-Fi signals, Bluetooth signals, and we have added one of our true RNGs to it, along with a storage device. And so this is actually this is going to capture just Bluetooth signals only within about 100 feet, depending. That's with line of sight. So if it's in somebody's pocket or in a car, it's going to be much less than that. And this, on the other hand, is going to go over 1,000 feet, and with a booster, if with a power booster in a car, it's kind of difficult to tell, but depending on the terrain, quite a ways. Capturing, if you could imagine traveling through a densely populated area, downtown San Francisco, for example, or through an airport, or downtown, any downtown area, you're going to be capturing thousands and thousands and thousands of mobile and stationary Bluetooth and Wi-Fi signals, and capturing all that information and uploading it to the blockchain. And in addition to all those signals, there would obviously be these interspersed in some way throughout those signals. And being mobile, instead of just waiting till you get home, you're uploading that live as you're traveling. And so that's much quicker turnaround for the data and an immense amount more. This is why here we would need, so imagine, let's say California actually wanted to take this on, and they enabled every rideshare driver who wanted to participate with one of these. The rideshare drivers would not only be contributing valuable data to the network, they would also be earning cryptocurrency just as they were traveling around and providing integrity to the system. When people got in their car, it would be registered. And I envision it to where people could go in for free and actually look up what their own data is.
and then maybe for fees go in and play around and look at other things and other data. But everybody would have access to their own data and all of this information. Everything I've shown you so far is all open source, and we've put all of our code that we're using on our GitHub page. And so this is kind of it in a nutshell for the how the mechanics, the basic mechanics of our XYO solution goes. But when you combine this with artificial intelligence and the machine learning, we could utilize these to identify hot and cold spots throughout geographic areas and empower both individuals, businesses, and governments on the current state of actual the network, the people network. And businesses through the app, businesses, you can see this traveling, you can run specials here, like this is a little bonus you got. You can do things like leave a bonus here for businesses that like a coupon. Somebody's traveling, so you could populate an area with coupons from businesses that are open, and then when people travel to that area, they get populated with that, and that's what they're looking for. And then with all of these, they could have access to, you know, what areas are where outbreaks are happening and where they're not, and we'll be even be able to project. So, for example, you know, looking at the data is great, what it is, but what happens if you're trying to plan something you need to go 2 weeks from now? There really isn't a tool out there for the public to accurately, you know, determine what's the best plan of action for that. And so with this device, that would give not only individuals, but the businesses who had to shut down and shift to different methods of reaching their customers could all do it through this interface.